Hi there. This isn't a lesson itself, it's just a wee extension, but I did mention before that a lot of the stuff we do in advanced higher physics actually explains things that go on in the real world. So what I'd like to do just very quickly, you don't really need to fully understand this, but if you listen to it, you might be interested. This is how the bits that we've looked at so far, you're going to obviously do problems and you're going to see how they apply to the real world, but this is something that maybe takes you a little bit beyond just for a couple of minutes and just shows you something that is slightly different. So far we've looked at S, we've looked at displacement, we've looked at velocity, and we've looked at acceleration. Now the displacement is obviously just the displacement. The velocity is the differential, the rate of change of displacement with time, so ds by dt. And acceleration is dv by dt, so the rate of change of velocity with time, which we can also write as d2s by dt squared. Now you might be thinking, okay, well that's displacement, that's velocity, that's acceleration. Well, what about if we went one further? There's a bit of a pattern here. So we went s, ds by dt, d2s by dt squared. What about this? Does this actually mean anything? Or is this just for a math teacher? Well, the reality is, yes, it does mean something. This we actually call, and some of these names are good, but the jerk or the jolt. Now, actually, these names are words that we use in everyday speech. If you're jolted around in a car, then it normally means that you've either gone over a bump, or you've suddenly turned the corner, or maybe you've suddenly hit the brakes. And it's basically telling you this is the rate. Well, if this is the rate of change of displacement with time, this is the rate of change of velocity with time. Well, this will tell you the rate of change of acceleration with time. And because acceleration is d2s by dt squared, that's d by dt of d2s by dt squared, and that gives you this thing here. So what about it? Is it just something that we're doing in maths? Well, no. These words aren't here for randomly. When we're talking about a jolt, so being jolted or being jerked around, we're basically talking about a change of acceleration. And this is really, really important. If you're designing a road, or if you're designing, say, a railway, or if you're designing a roller coaster, then you need to have a really good understanding about this thing here. There's a lot of stuff that actually people don't notice, and you wouldn't have noticed it, and I probably didn't notice it until I knew about this. But when you're designing a road, what you don't do is you don't just have it coming up here and then immediately start turning a corner. Some smaller roads do this, but certainly no motorways and no A roads would ever do this. What actually happens is, in reality, is that the corner, when you start turning the corner, because we'll find out later on, you're actually accelerating. When you actually start turning the corner is gentle at first. And then it gets steeper and steeper and steeper. And then it gets gentle as it goes out here. You'll have to excuse my drawing. My drawing's not very good to show this. But the point is that you start the corner off gently, and then you make people turn into it much more greatly. So when you're learning to drive, if you're going along especially faster roads, you might find that the beginning of a corner, especially in something like a motorway or an A road, is actually quite gentle. But as you go into it, it becomes steeper and steeper and steeper. All railways are designed along these principles, and so are all roller coasters as well. I've been in a couple of roller coasters where I think the point of it is to suddenly turn corners. It actually hurts quite a lot. There's one called the Mighty Mouse that used to go along and do virtually 90-degree corners. And it wasn't actually that much fun. It's more of a painful experience than a thrilling experience. Most roller coasters are designed so that when you go into a loop or a banking, that you actually start off quite gently. It's only actually when you get to the top of the loop that you turn very, very rapidly. And this is because our bodies don't really like being put through sudden changes of acceleration. So this stuff here is used. It's used every day. There is a term beyond that as well, which is d2s by dt to the 4. And this is called something else, and I can't actually even remember what it is now. I've got it written down there. Oh, this is actually called, yes, the jounce. Now, to be honest with you, I don't really know much about that, and I'm not really going to go into it at the moment, but certainly there are applications for that. And believe it or not, there's one beyond that still, which would be the rate. This is the rate of change of jerk with time, and this would be the rate of change of oh, sorry, that should be a 5. 5, I've done that. 4 there, 5 there, 5 there. The rate of change of jounce with time, and believe it or not, this is actually called the crackle or pop, and it could well be that has some relation to Rice Krispies. I have no idea, but there you go. One other wee thing as well, something that probably probably makes a bit more sense when we put it in this way. See, we go back to the beginning again. The unit of displacement is meters. The unit of velocity is meters per second. The unit of acceleration is meters per second, or another way of putting it is meters per second squared. And the unit of jerk or jolt is actually meters per second cubed. And apparently, so I read on Wikipedia, I'm not an expert in this, but in railways, that the designers actually have a maximum jolt of 0.35 meters cubed per, meters per second cubed as the design goal, and they have an absolute maximum of 0.5 meters per second cubed. I guess that's so that your coffee doesn't go flying off the table. The curve that they use here, if you're interested, is sometimes called a Euler spiral. Anyway, that was just a wee side thing. Thought it was quite interesting. Just wanted to put it up there for you.